All right, a proton traveling 4.81 times 10 to the 6 meters per second in the plane of this page travels anti-clockwise in a circle with a radius of 2.87 millimeters. What is the magnitude and direction of the magnetic field that affects this? This effect is not like to change. This is effect as in to cause. It's the verb form of the EFFECT. Just, there it is, right? Okay, so here's a trick. Look down at your part E and draw a picture of this proton going to the left. Okay, so here's this proton. I'm going to draw it over here. It's going to the left. Now, it's going anti-clockwise, right? So anti-clockwise would mean that it's going in a circle like this, yeah? Okay, the only way for that to do that is that the magnetic force is this way, yeah? This is our velocity. The only way to go anti-clockwise if you're going left is for that force to be down the page, okay? This will be important. This will actually be important here, okay? To solve the first part of this problem, all we're going to do is we're going to say QVB, the magnetic force, is centripetal force, so mv squared over r, okay? And then we are trying to solve for B, so go ahead and just cross multiply, solve that for B, right? B will be mv squared over r, and then we'd have to divide by QV, right? Okay, which is one of the V's cancels, right? So it's mv over rq, right? And now we can just plug those numbers in, right? The magnetic field is the mass of the proton, right? And you got to look that up in the data packet. 1.673. It's in one of those front pages, times 10 to the minus 27th. Right. So look at what it is. Don't just assume it's an electron or a proton or whatever, right? Okay. The velocity is 4.81 times 10 to the 6th. Okay. And then we're dividing by the radius, which is 2.87 e minus 3. And then our q of a proton is, of course, 1.602. There we go. Okay, so 1.673 e minus 27 times 4.81 e6 divided by parentheses 2.87 e minus 3 times 1.602 e minus 19 n parentheses. So put that denominator in uber parentheses, right? 17.5 is my Teslas, right? Okay, now, how do you exert a force down the page on a proton? Well, it's a proton, so it's easy, right? So make your index finger go this way, right? Make your thumb go this way. Okay, so index finger's there, thumb is there. Okay, now notice that your middle finger is into that page, right? So the middle finger is B, and in this case it's into this page, right? So 17.5 Teslas into the page is the answer to this, yeah? Okay, now because we drew a picture of this thing and said, okay, look, to go anti-clockwise the force is down like that, right? Now it's easy to figure out the direction of the electric field. So let's figure out the direction first. To make it go straight, the magnetic force is acting down and making it go in an anti-clockwise way, right? It's going this way and this way and this way, okay? So to counteract that downward force, we have to have an electrical force up the page. Now this is super easy. If it's a proton, the way that you exert a force up the page is you have an electric field that really is up the page, okay? So the answer is up the page, okay? E would have to be, right? Because the force has to be up the page, right? And then to figure out the electric field, what you need to be, right? You just set the magnetic force equal to the electric force, right? Remember, the magnetic force is QVB, and the electric force is what is it? It's EQ, right? Okay. The charge does cancel, and by golly, the electric field is the velocity times the magnetic field, right? Okay. So we're going to take that magnetic field we got in the last problem and go times 4.81 E6. Whoops. And I get this giant number. that my TI calculator does not help me with. 84186,350. Honestly, you couldn't put commas in there. Okay, let's see. That is 8.42 times 10 to the 7th newtons per coulomb. And then we figured out that it has to be up the page because magnetic force is down the page. The electric force would have to be up the page to counteract that. Now, I challenge you. You guys are talented and gifted. I challenge you to come up with your own rule. Your own rule. For, like, what would you have to take into account? The velocity and the magnetic force. Come up with a rule that tells you the direction of the electric force. There should be some way. You should be able to come up with your own rule. Of course, it will be obscure and you might forget it, But anyway, there it is.